Let's do a second.
It's 5:30. Let's go and get started. All right, good evening, everyone. How's everyone doing today? Good, doing good. All right, let me first start off by saying my wife is beautiful. I love my wife. She's a wonderful person, right? I told her what happened on Monday about how I made fun of her and then I started coughing like crazy and she said, serves you fucking right. So don't mess with me again in public time. Another funny thing that happened is that I may have kind of almost forgotten that tomorrow's our wedding anniversary. And so I was talking about, maybe going to work out tomorrow. In my defense, I remembered the wedding anniversary up to, up about a month ago when I was trying to plan something for us to go out, but she couldn't decide on a place to eat. So then, kind of just forgot about it until yesterday. So yeah, not a great week for Justin, the husband, this week. Okay, all right. So the plan for today is, we're going to finish up our review of MATLAB. And so we got about 60% done. So I think today we'll finish it up. We had a little bit more statements. We're going to cover 4 loops, and then I have a few examples that we're going to go over as well. Okay. I know people have been working on the homeworks, and so definitely, make sure you're working on that. And I think hopefully after today, once we cover loops, once we kind of review that, and you've looked at a couple of the examples that I have today, I think it'll make the homework a little bit easier to do. Okay. Because so this happens every year. So I've talked to a few people who've already been working on the homework that that you can produce the output that I'm looking for on the MATLAB problems in a different way. But I'm asking you to kind of do them in a very specific way because the style that we're going to be using in this class, is really going to help us out kind of later on. And so even if you are able to kind of get the outputs that I'm looking for, maybe with the loop slightly modified or maybe with the indices slightly modified, yes, it would work for that problem. But the way that we do things in this class, it helps a lot to kind of program in a specific way, and we'll talk about that a lot in today's class. Okay. Okay, I think that's it for announcements. Are there any questions I can answer before we get started today? Okay, all right, so let's go ahead and pick up where we left off. Okay. And we were talking about if statements. Okay, so let me actually come back up here. Okay. So, I would say that in terms of programming, programming specific skills, I would say that if statements and for loops are probably going to be the most important thing that we'll need because it's, we'll be using them a lot in this course. Okay. And so on Monday, we started talking about if statements, and if statements are basically these programming constructs that you can use when you want your program to do different things in different situations. Okay. A lot of times those different situations are governed by the value of certain variables. Okay. And so if you look at some of the examples that we did last time, and so, in particular, this one right here is a good example. Okay. Oftentimes when we're writing our code for this course, we're going to have variables that are tracking certain things, okay? Whether those variables are tracking, maybe the location we are in the physical domain, or maybe those variables are tracking, the value of certain parameters like the velocity or something, okay? And then depending on the values of those parameters, we want the program to compute something different or maybe do something different, okay? And so if statements are our way to do just that. Yeah, question. Oh, yeah. Let's see. Okay, I set it to 70, I think. Yeah, so it should heat up a little bit. Okay. All right, so on Monday we went over just kind of basic if statements where you just have one conditional. Okay, so you have one conditional inside the if statement, and then we also went over this idea of an else if, where maybe you want to check more than one conditional. Okay, and so you have basically a first Boolean check that you would check. If that one returned false, then you would go to the next one. That would be in the else if, and if both were false, then you wouldn't do anything inside the if statement. Okay, so the last the last part of the trilogy for if statements is the else statement. Okay, and so let's say that you're writing an if statement. It could be just an if statement. It doesn't have to be else if, and so it could be if, else if, or just if else. Okay, and maybe you want the if statement to do something in case all the other conditions fail. Okay, and so the else here really means like if all else fails, then do this. Okay, because for the cases that we looked at so far, so for the if, just the if statement by itself and the else if all the conditions fail or all the conditions return false, then the program is just not going to do anything. It's just going to skip over all that code. Okay, but maybe you wanted to do something in case everything does return false, and that's exactly what the else statement is for. Okay, and so the structure of the if else statement looks like this. And so you're going to have a section of code that is given by else right here. Okay. And so, in this case, we have an if and an else if. And so if condition 1 fails, if condition 2 fails, then we do the work in the else statement. Okay. All right. So here's a quick example. Actually, let me go ahead and type this out just so we can see it in action. Okay, so here is our code from last time. And so we have a variable here called needs correction, and we set its value equal to 3. Okay. And so we have an if statement here. So if that variable needs correction is less than 1, then we're going to correct its value to 1. Okay. Else if that needs correction value is greater than 7, then we're going to correct its value to 7. Okay. But if the needs correction variable is between 1 and 7, both of these conditions are going to return false, right? And so in this case, it actually does do that. And so we have needs corrections equal to 3. 3 is in between 1 and 7. And so nothing is going to get executed inside this statement. Okay. But if we did want the if statement to do something, we could add an else here. Okay. And so that else is going to be something that gets executed if this condition and this condition return false. Okay. So let me see what I have here. Okay. Okay. And so in this case, if we kind of fail both other conditions, then in the last case, we're going to set needs correction equal to 4. Okay. And so if I run this code, the needs correction, its value should change to 4. Okay. So we start at 3. It's going to fail both of these conditions and then come down to the else statement and get set to 4. Right? So let me go ahead and run the code. Remember, where you should be looking is kind of in this workspace right here. So the workspace is going to be where we see our variable. Okay. Let me go ahead and run the code. Okay. And then just like I promised, the else if both failed. And so we go to the else. And so then we return 4 right there. Okay. All right, so the else statement is going to be useful. We'll use it a lot in this class because there are cases where it's going to be useful because we'll check for a couple conditions. Maybe we'll check a couple locations, either in a matrix or maybe in a physical domain. And if those are false, then we do something else. Okay. All right. Any questions on the else statement? Okay. All right. So let's go ahead and talk about loops now. Okay. For loops. And so, I'm aware that there are two types of loops. And so there's for loops and while loops. But for the purpose of this class, the one that we're going to be using the most by far is going to be for loops. In fact, I don't think we'll use while loops at all. You can certainly write some of the codes with while loops. You can kind of restructure them, but I think, just for, just the nature of the codes that we write in computational heat transfer and CFD, for loops tend to be a lot more useful just because of, how much control you have over them. Okay. All right. So what is a loop? And so a loop, whether it's a for loop or a while loop, is basically a programming construct that you can use to repeat a set of code. Okay. And so maybe you have a set of code here and maybe you want to repeat it, several times. One way that you can do it is you can just write the code, just kind of copy and paste the code several times over. And technically, you could do that, but a lot of times the more convenient way to do it would be with a loop. Okay. In particular, the reason we like to use loops a lot here is because we can have the loop react kind of in real time to the size of a problem that we may be considering. Okay. And so let's look at the anatomy of a loop. Okay. And so kind of all the action is given in this first line right here. Okay. Okay. And so we have to define three variables here, one variable and two numbers basically. Okay. And so the first thing we're going to define here is what's called the loop index variable. Okay. And so you can almost think of the loop index variable as like a way to keep track of which iteration of the loop that you're in. Okay. Because a lot of times when you write a loop, you want it to repeat, quite a few times, usually something like 25 or 50 times. And so the program has to have a way for you to keep track of, which iteration of the loop that you're on. Okay. And so that index is basically keeping track. So, we did the first loop, right? Now we're on the second loop. Now we're on the third loop, and then it keeps up like that. Okay. All right, so the loop index variable is very important, and we can actually use that in our programming pretty useful in a useful way as well. Okay. Okay, and so the next two things that you have to define are both the starting value for the loop index as well as the ending value for the loop index. Okay, and so the starting value is just whatever is going to be starting. So most of the times you're going to set the starting value equal to 1, because that kind of just makes the most sense because we start counting up from 1. And then the stop value is just the maximum value for the loop index. And so oftentimes this is going to be the one that we manipulate quite a bit. Okay. Okay. All right. And so one of the more common uses for a loop is to visit every entry in a vector or visit every entry in a matrix. Okay. And so that's what we're going to use loops for a lot. And so let's look at this kind of very brief example here. And so let me go ahead and type it out. So let me go ahead and delete this. Type clear. Okay. And so let's say that we have a vector. Okay. And so the vector is just going to be an empty vector that has 5 entries. Okay. Remember, we're using our specialized function zeros here. So the zeros function basically creates an empty vector for us, okay, where all the entries are 0. We can go ahead and run this code just for now, just so that you can see. Okay. And so I ran this code, and you can see here that the loop vector is indeed a vector with 5 entries, and they're all 0. Okay. And so what I want to do is I want to write a for loop. Okay. And so what this for loop is going to do is that it's going to set a value for every entry in this vector. Okay. And in fact, the way that we're going to set it, let me see the way that we set it. It's going to be all the even numbers. Okay. All right, let's do this. Okay, so let's go ahead and start our for loop. And so our for loop always starts with 4. And so when you type 4, it highlights blue. Okay. Let's go ahead and give a name for our loop index. So you'll see me use the word index a lot. You don't have to use index. You can call your loop, you can call your loop variable anything you want. But index is the word that I like to use. Okay. We're going to start this loop at a value of 1, just because we like to count up from 1. And if we look at kind of the prompt for this loop, we want to visit and set basically every entry in this vector. Okay. We look and see the size of this vector. This vector has 5 entries. And so we're going to set the stock value here equal to 5. Okay. And one thing I like to do, just so I don't forget it, and I do this for if statements too. So whenever I write a for loop, I like to just write end right away, just so that I don't forget to. And so whenever I type a for loop, I just go hit enter. I go to the next line, and I type end, and then that's going to be that encapsulates our for loop. Okay. All right, so let's go ahead and finish up this this code here. And so we want to basically set the loop vector. And so we're going to use our variable setting notation here. And so we're going to access basically each entry in the loop vector. And so we're going to do this by using the loop index itself. Remember, the loop index, what it's going to do is that each iteration of the loop, it's going to count up by 1. Okay. And so by using this code right here and taking advantage of the fact that this index is going to go 1, 2, 3, 4, 5 on each iteration of the loop, we can use that to access the appropriate entries of the vector. Okay. Okay. And so we have 4 index is equal to 1 to 5. Loop vector at index is equal to 2 times index. Okay. Right. And then again, on the right, we're making use of the index variable again, because we know that this index is counting up. All right, so let me go ahead and run this. Okay. And you can see our workspace here is updated. So now we have, our loop vector has all the even numbers associated with it. And in fact, the workspace also saves our loop variable as well. And so you can see index. By the time our program concludes or at the end of the program, our loop index has its maximum value, which is 5. Okay. Any questions on this? Okay. All right. So, I want to kind of write this code in another way because, this would probably be the best way to write it. It's a 3 lines of code. But I think oftentimes it's a little bit of a struggle to kind of visualize what's happening in the loop. Okay? And so, I really do mean it when I say that, a loop is just taking the same code and then just copying and pasting it 5 times. Okay? So what I'm going to do is I'm going to recreate this code and kind of show you what's kind of happening on the inside. Okay. Okay. And so this loop is repeating 5 times. And so, I'm basically doing the same thing. So let me go ahead and comment this out. Okay. So now this code is not going to be active. In fact, let me clear this just so that, you don't see everything over here. Okay. But I'm going to produce the same output as that loop, just purely manually. Okay. You would never do this in practice. You would never just copy and paste code, but I'm just mostly just doing this just to illustrate kind of what's happening inside them. All right, so what I'm doing basically is I'm writing the code here to update the index variable. Okay, and what I'm going to do as well, lower this. Okay, so that's going to be the first iteration of the loop. And so on the first iteration, the index variable is equal to 1. Okay, that's the second iteration. Fourth iteration and the 5th iteration. Okay. Okay. All right, so hopefully this kind of gives you a better visualization of kind of what's happening in the loop. And so if you look at the loop body, which is basically just these lines right here, okay? These lines are all the same, right? Because those are the ones that are inside the loop itself, okay? And so we're basically repeating the loop body over and over and over again, okay? What's changing at each loop is the value of the loop index, okay? So, we're starting with the value of 1 because that's how we define our for loop here, okay? And then each time the loop iterates, or each time the loop kind of comes back, we move on to the next, the next value for that index. Okay, so we start at 1, we go to 2, 3, 4, 5. Okay. All right, so let me go ahead and run this code, and then what you'll see is that our result here is going to be exactly the same. Okay. Right, and so if you kind of remember what our result was before, we had our loop index equal to 5, and so that's true here too, because by the end of the 5th iteration, our index was 5, and our loop vector here has the same values, and so it has all the even numbers 2, 4, 6, 8, 10. Okay. All right, and so if you're ever kind of struggling to kind of figure out what a loop is doing, in this case, it's not too difficult because it's just a very simple loop. But for the homeworks and for the especially for all the codes that we're going to be writing this semester, our loops are going to be quite complicated. So there's going to be quite a lot going on. And so, if you're ever confused about what's going on in a loop, it wouldn't hurt to do something like this just to help you kind of visualize and see what's going on. Because I think the number one thing that I think trips people up, especially early on, is making good use of this loop index here. Okay. All right. Any questions on this? So let's come back to the slides. And this is just kind of a text version of kind of what's going on in the loop. Okay, so this, we kind of just went over this by hand. Okay, next let's talk about nested for loops. And so, you're not limited to just having one for loop by itself. You can put a loop inside a loop, right? For lots of loopy fun. Okay. And this is really useful because, in the last example, we used a loop to visit every entry in a vector being a one-dimensional construct. You can use a nested for loop to visit every entry in a two-dimensional construct, like a matrix. Okay. Okay, so the syntax is like this. And so you have an outer loop. Okay, so you have an outer index like this, and then you have an inner index just like that. And you put the inner loop basically completely inside the outer loop. Okay. And so if you look, you can see here we have two end statements. And so this end statement is going to be paired with this loop. Okay, so that's why we call it the inner loop, because it's completely inside the outer loop. Whereas this one, these two are paired just like that. Okay. All right. So how do you interpret this? How do you interpret a nested for loop? And so basically, you can kind of think of it the same way. It's just that, the inner for loop, this inner for loop itself is going to repeat many, many times. Okay. And so basically the way that you can think of it is that each time the outer loop iterates, or each time the outer loop updates, the inner loop will complete a full cycle. Okay. And so if you look at the total amount of times the code is going to be executing each loop, the outer loop only gets executed once, but the inner loop, makes a complete cycle, however many times that you have in your outer loop. Okay. And so the analogy I like to think about for a nested for loop is you think of a clock, an analog clock, not a digital clock. Okay. And so the outer loop is something like the hour hand, okay? Whereas the inner loop is something like the minute hand. Okay. And so in order for the hour hand to kind of progress from one time to another, the inner loop or the minute hand has to make a full rotation. Okay. And so in this analogy, the inner loop here is the same as like the minute hand, and the outer loop is the same as the hour hand. Okay. Okay. All right, so let's look at an example of using this to visit entries in a matrix. Okay, so let me go ahead and let's type out this example here. So let me go clear all this. Okay, and so let's go ahead and make a matrix. And so I'll call this nested matrix. And just so that you can kind of see what's going on, I'm going to give it a different numbers of rows and columns. Okay. And so we'll say the matrix has 3 rows and 5 columns. Okay. And then what I want to do is I want to write a loop or nested for loop to visit every entry in this matrix and set its value equal to a counter. Okay. All right, so let me go ahead and run this just so you can see what the nested matrix looks like. Okay, so if you look at this nested matrix here, you can see it's empty because we use the zeros command. But you can see it's a 2-dimensional construct. And so, we have 3 rows and 5 columns. And so if you count the total number of entries that we have, it's 15, okay? Okay. And so the best way to kind of visit every entry in a matrix like this is to write a nested for loop, right? And so we can have one for loop that visits, that goes down the rows. Okay? So you can see here, I'm using a different name for the loop index. And so instead of just index, I'm calling it row index, okay? And in this particular matrix, we have 3 rows. And so I'm going to say our row index goes from 1 to 3. Okay. And so this 3 right here is kind of mimicked right here. Okay. Okay. Then I'm going to write another for loop inside of this. And this is going to loop over the columns. And so for the number of columns that we have in this matrix is 5. Okay. And so I'm going to reflect that right here. Okay. Okay. All right, and so now we can use this for loop to visit every entry in the matrix. Okay. Okay. So let's see, what did I do here exactly? Count is equal to 1. Okay. Okay. So basically, we want the matrix to end up looking something like this. Okay. So I'm going to clear these, and so we want the matrix to basically count up 1 to 15. Because we have 15 entries in this matrix, okay? And so for this particular problem, we need to basically keep another variable called counter or count that's gonna keep track of that, okay? Okay. All right, so, so this is kind of another concept that I'm introducing here, which is, I call it a counter variable, okay? So this is a variable that, we're updating, and so we're gonna update its value as we go through the code. But we're going to update it kind of, separately from the loops, okay? Because the loops already have their own way of keeping track of their iterations using their own index. But sometimes we want to keep count, or we want to keep a variable to keep track of something outside of that loop structure, okay? And so we're going to call that variable count. Okay, so this counter variable, we're going to start at 1, and then basically what we're going to do is that each time the loop iterates, or one loop iterates, we're going to update the value of count. Okay. All right, so let's do this. So we're going to say count is equal to count plus 1. Okay. And so what that does is that each time the inner loop makes an iteration, we're going to update the value of count. Okay. And then besides that, we're going to set the value of the appropriate matrix entry to that count variable. All right, so you're going to see me use both indices here. So we're going to use both the row index and the call index. Okay. And so we're going to say nested matrix, and then we're going to set the entry equal to at the row index and the call index. Okay. And this is going to be equal to count. Okay. All right. And so if we run this code, it should produce the following output. Okay, so let's go ahead and run it. And you can see that our output is exactly this. Okay. All right. So there's a couple concepts in this example here. So there was of course there's the nested for loop. Okay. Which in this case, we use the nested for loop to basically index or basically visit every entry in a matrix, which is a 2-dimensional construct. Okay. And then we also made use of a counter variable here to kind of, have an additional variable that's being updated outside of the loop indices. Okay. And you'll see this very common. This is pretty common when you have a nested for loop, because sometimes you want to counter kind of outside. Okay. All right. Any questions on this example here? All right, and then finally, we can combine our two kind of programming constructs. We can have an if statement within a for loop, right? And so, we're kind of throwing everything out here. Okay, so this is really useful, and so you'll see if statements in for loops quite a bit. And so, what this is primarily useful for is that you can have the if statement basically tell the loop to do something different on every iteration. Okay. Because sometimes you, depending on which, iteration of the loop that you're on, which, can mean which, depending on which area you are in the, in a physical domain, or maybe a certain area in a matrix, you want the program to do something different. Okay. Okay. So for example, let's say that we have a vector here called even vector, and we want a loop to visit every entry in this vector, but we only wanted to set the values of the even indices. Okay. And so let me go ahead and write that. Let's go ahead and write this code here. So clear this. Okay, so we'll say even vector. And just so it's interesting, I guess we'll do 20 entries. I made it 20 by 1 just so it's a little bit easier to see. So 20 rows. I think I did that here too. Okay. Okay, so let's go ahead and write a for loop. So we'll say for index is equal to 1 to 20. Okay. Because we have 20 entries in this vector, we want to basically visit 20 times. Okay. But we want to write this code such that we only visit the entries with an even numbered index. Okay. Okay. All the odd number indices, we're just going to leave it alone. So we're just going to keep those at 0. All right, so let's go ahead and do that. And so, we're writing a for loop. And this for loop is going to visit every entry in this vector. Okay. But we wanted to ignore the odd numbered entries. Okay? And so to do that, we're going to write an if statement that's going to basically make that happen. Okay. Okay, so let's write our if statement. And so we want the code to ignore the odd number indices. Okay, so to do this, we're going to use a function called mod. Okay. And so if you've never used the function mod before, the mod basically takes a integer division, or basically a whole number division of two numbers. And then instead of giving you the result of the division, it gives you the remainder. Okay. Let me go ahead. Down. Let's use the mod, okay, which returns the remainder of the division of two numbers. Okay. And so we want to divide two numbers. And so the first number that we're going to divide is the index. Okay. And then we're going to divide it by 2. Okay. All right, so why is this significant? And so, this is kind of the way that you can tell whether a number is even or odd, right? And so if a number is even, when you divide it by 2, you should get remainder 0, right? And so, that's kind of the definition of an even number. But if you have an odd number, let's say 9, 13, 25, something like that, when you divide it by 2, you're always going to get remainder 1. Okay. And so to check if this is an even number, we want to see if this mod is going to return 0. Okay. And so if this mod here returns 0, that means we are an even number. Okay. So what did I call this again? Even vector. And then all we're going to do is that, if we are at an even index inside the vector, then we're going to just set its value. Okay. Okay, so let me go ahead and run this code. And so if we wrote this code correctly, all the odd number entries are going to be 0, and all the even number entries are going to match kind of their index. Okay. Okay, so let's go ahead and look at the code. So if you look at the entries in this vector, it kind of does exactly what we want to do. So, all the entries in slots 1, 3, 5, 7, 9, 11, all of those are still 0. Meanwhile, all the even entries are 2, 4, 6, 8, 10, 20, and so on. Okay. Yeah, question.
What if we would have set it from 0 to 20?
0, which one? The loop index?
Yeah.
So you wanted to set it from 0 to 20? Just like that?
Mm-hmm.
Yeah, so this is going to return an error, because what's going to happen is that you're going to try to access the index at 0 right here, and then MATLAB doesn't that's not existent in MATLAB, because the first entry is always the first one. Yeah. So we can run it and we can see. Yeah. And so you're going to get this error that says array indices must be positive integers or local or logical values. Yeah. Right. Any other questions on this example here? And so, for those of you who are savvy with MATLAB, probably you're thinking, there's a way to write this code without an if statement. And you're right that, we can change these indices to go from 2 to 20 with an increment of 2. And so that is possible, but the reason I did this example the way I did was just so that you can see what an if statement inside a for loop looks like, because we'll be doing other cases like this later on. Okay. All right, and so with that, I have a couple more examples that I want to do together. Okay, so these are kind of more reminiscent of the problems you're doing in your homework. Okay, so we'll go ahead and do these together, so that you can see kind of my thought process and kind of see how I would write this code. Okay. All right, so first example, and so we're going to start with an empty 5 by 5 matrix. Okay, and what I want to do is I want to fill each row of the matrix according to the following criteria. Okay, and so the first row we're going to start with 2. Okay, and then each subsequent entry in that row is going to count up by 2. And so the first row is just basically going to be 2, 4, 6, 8, 10. Okay. All right, in the second row, we're going to start counting at 3. And we're going to count up by 3 in each subsequent entry. The second row is going to be 3, 6, 9, 12, 15. Okay. Third row, we're going to start at 4, and then we're going to count up by 4. Fourth row and fifth row kind of the same way. Okay. All right, so let's go ahead and break this down. So let me go ahead and clear this. And clear our code here. And let's kind of dissect this kind of little bit by little bit. Okay? So the first thing that tells us that we're going to start with an empty 5 by 5 matrix. Okay? So I'll call this matrix example 1. And so, we know how to create an empty matrix. And so the empty matrix, we're going to use the zeros command. Okay. And to make it 5 by 5, all we have to do is we have to give it 5, 5 inside the arguments of that zeros command. Okay. Okay. So that's good. So that's kind of the first step here. Okay. The next line tells us that we want to fill each row of the matrix according to the following criteria. So, this basically tells us that, we're going to be we should visit every entry in the matrix because we're going to be setting its value. Okay. And so, we've already seen an example today of how to visit every entry in a matrix. The best way to do that is with a nested formula. Okay. I'm going to use a nested for loop to visit every entry in this matrix. Okay, so I'm going to write it in kind of the same way that we did before. So we're going to have a row index that's going to go from 1 to 5. Okay. And then we're going to have a call index for columns. And this is going to go from 1 to 5 as well. Okay. All right, and we can jump ahead even a little bit more because the purpose of this nested for loop is to basically set the values of every entry in the matrix. And so to set the value of a matrix inside a loop, we're going to have the name of the matrix. And so that's matrix EX1 in this case. And then we're going to make use of the loop indices, row index and column index. Okay, so we're going to have row index, comma, call index. Okay. And we're going to set that equal to something. Okay. And so far that's all that we've been able to write kind of based on the knowledge that we have. And so we have our empty matrix. We have our nested for loop that's going to visit every row or every location inside the matrix, and we've kind of started the code here to basically set the values in that matrix. Okay, so now the fun part, and so now we need to basically write the code to satisfy everything else in this problem. Okay, all right. So in the first row, we're going to start with 2 and then count up by 2. Okay. And so, the fact that, we're counting up here, okay, so basically each time a loop iterates, we're going to count up, this kind of gives us a hint here that we should use a counter variable. Okay. So let's go ahead and specify that. And so we're going to say count. In this case, I'm going to put the counter variable inside the outer loop, okay, but outside the inner loop. Okay, and you'll kind of see why in a second. And we know that we want this counter to start at 2 for the first iteration, 3 for the second iteration, 4 and 5. Okay. And so if you look at kind of what the counter is going to start at each row, it's always 1 plus the row number, right? And so for row number 1, we're starting at 2. For row number 2, we're starting at 3. For row number 3, we're starting at 4, and so on and so forth. Okay. And so what I'm going to do here is I'm going to start this count variable. And I'm going to start it with the row index, okay? Okay, because the row index tells us, which row we are in the matrix. Okay, and then to that I'm going to add 1, okay? Because we're starting the count at 1 plus that. Okay, all right. So now that we have the counter variable, we're updating it on each row index. Let's go ahead and set that for the matrix example, or for the matrix specification. Okay. And I'm going to go ahead and set that to count. Right, so we're not quite done yet. But this is a good start. And so, don't be afraid to kind of run your code and kind of debug along the way. Question, yes. Correct, yeah. So count here is a variable. It's a counter variable that we're using to kind of keep track of something. Yeah. Mm-hmm. And I know I kind of talked through this really quickly. I think, kind of the way I said it makes it seem kind of obvious because, I've given this lecture probably like 7 times now, but a lot of times it's hard to kind of see the patterns in these kinds of problems. And so, I don't expect you to look at the homeworks and basically get the solution to those programming problems kind of as quickly as I'm doing here. It's going to take time. It's going to take some mistakes, and that's okay. That's kind of the whole point of this practice. Right? The only reason I'm going through it fast right now is because we have a limited amount of time in the lecture. But don't be afraid to kind of try some stuff, make some mistakes, and then kind of debug from there, because that's honestly the best way to learn programming is to just try it, get some problems, try your best, see where you went wrong, and then debug it. Okay. And so in the spirit of that, we're not quite done yet. There's one more line that we have to write, But let me go ahead and run this code as it is right now, just so that you can see what the result looks like. Okay. And so what we should get is this. Okay. And so we should get a matrix where, for the first row, we're counting up by 2s, second row, we're counting up by 3s, and so on and so forth. Okay. But if we look at the result that we have right now, that's not exactly what we have. So for the first row, okay, we start at 2, so that's good. So that means we're on the right track. And the second row, we start with 3 and 4 and 5 and 6. Okay, so the starting values are all good. The unfortunate thing is that we don't really count up from there. And so the rest of the matrix is kind of wrong. Okay. And so we have a little bit of debugging to do. But that's okay. We can go ahead and do that. And so let's go ahead and look back at our code here. Okay. And so let me go ahead and leave a note. And sometimes, and I do this all the time in my code too. So when I'm debugging something or when I'm developing a code and it's not quite producing what I want to produce, I leave a comment in my code to kind of tell me exactly what's wrong so that I can, kind of more easily go back into the code and look at it. Okay. All right. And so based on our outputs, we are setting the first entry in each row correctly. Okay, so that's good. But each subsequent entry in this row is still the same as the first entry. Okay. Okay, so that's kind of the issue that we're kind of working with right now. Okay. And so basically we need to make the adjustments to this code, or we need to correct it such that we can kind of fix that error. All right. And so the way we can fix this error is we could say that it seems like we need to update the value of the counter variable inside the inner. Okay. Right. And so if you look at kind of the code right now, the inner loop, we're using the counter variable as we should, but the value of that counter variable is not really updating. So it's kind of just being stuck right here. Okay. And so we need to basically update its value. So we're going to say count is equal to count. Okay, so we're using basically our update notation. And so inside the inner loop, we're not updating, or we're not replacing its value. We're just kind of adding to it. Okay. And remember, we want to add, we want it to go up. The amount that we want it to go up in each inner loop depends on which row that we're in, right? And so on the first row, we count up by 2. In the second row, we count up by 3. And the third row, we count up by 4, 5, and 6. Okay. Okay. And so to do this, I'm going to go ahead and copy this code right here, because this code kind of does the same thing. Okay. And so what this will do is that, for each time the inner loop is going to update, or each time the inner loop iterates, the counter variable is also going to update its value, and the amount that we're updating it by is 1 plus whichever row that we're in. Okay. All right, so let's go ahead and run this code. And you'll see now that this matrix has the right values that we need. Any questions on this example here? Again, I know I went really fast on that, and the way I explained things, made it seem like it's obvious, but that's because I've given this lecture, so many times before. So, to look at a problem and kind of pick out kind of what's the most important features, the most important details, and then, how do you kind of encapsulate that in code? The only way you kind of really get better at that is just through a lot of practice. Okay. So that's why, I gave a lot of programming problems in this homework. So I realize it's a lot. So I think there's like 6 or 7 of them. And, the purpose of that is just to give you practice, because the only way you really get better at programming is to practice. And so you write a lot of codes, and through writing a lot of codes and getting a lot of errors and getting a lot of things wrong, that's kind of the only way that you improve. Okay, so let's look at one more example. All right, and so in this case, we're just looking at a vector. Okay, And our vector here is going to have 25 entries. And we want to loop over each entry of this vector and modify the values according to a criteria. Okay. And so if the index is odd, then we're going to set the entry equal to 1. If the index is a multiple of 4, then we're going to change this entry to 4. And in all other cases, we're going to change the value of the entry to 24. So if you look at kind of the result, this is kind of what the result looks like just right here. Okay. Okay. So let's go ahead and write this code. So I know I just kind of showed the example. I showed the solution right there, but we'll go ahead and write it from scratch. Okay. So we go ahead and clear this. Clear this. Okay, and so we'll call this vector ex2. Okay. And so the first thing the problem tells us is that we need to start with an empty vector of 25 entries. Okay, and so we're making use of our zeros function again, and we're making it 25 deep this time. Okay, so 25 entries. All right, we also know that we're going to visit every entry in this vector. Let me go ahead and write a for loop for that. And so we're going to have 4 index goes from 1 to 25. Okay. And so all that is good. Okay. And then inside this loop, we're going to set values of this vector according to which index that we're in, or which entry that we're visiting. Okay. Okay. So let me go back to the problem statement here. Okay. And so this problem statement basically gives us three different scenarios. Okay. And so if the index is odd, we're going to do something. If the index is a multiple of 4, we're going to do something. And in all other cases, we're going to do something else. Okay. And so if you look at kind of this problem statement, then you can see that it's already kind of written in if statement format. Okay. So we're going to use an if statement. In fact, we're going to use an if, else if, spell, and else. So for the if and else if, we're going to write parentheses because we need to give conditionals for those. For the else, we don't need to write a conditional. In fact, it would probably give you an error if you wrote a conditional there. Okay. Okay. All right. So let's do the first if. So the first if here is, if the index is an odd variable. Okay. All right. So let's do that first. And so we're going to use the mod function. So the best way to determine if a variable is odd or even is to use mod, because remember the mod gives you the remainder. Okay. Okay. And so if we want an odd number, then we're going to take the division between index and 2. Okay. And for an odd number, this is going to be 1. Okay. Because remember, for an odd number, you divide it by 2, you get a remainder of 1. And so in these cases, we're going to set that entry equal to 1. Okay. And so to do that, we're going to do vector ex2 at the location index. That's going to equal to 1. Okay. Okay. All right. Next thing we're going to check and see if the index is a multiple of 4. And so once again, we're going to use the mod function, but in this case, we're going to do mod 4. Okay. And so if the index is a multiple of 4, when you divide it by 4, then it's going to give you 0. Okay. Once again, we're going to set a vector ex. We're going to set its value to 4. Okay. Okay. And so in the cases where our index is not an odd number and it's not a multiple of 4, so basically it's an even number that's not a multiple of 4, okay, we're going to set its value equal to 24. Okay. All right, so this should work right here. It seemed like I wrote more code here though. So what did I do? I just used longer names. Okay. Okay, so let's go ahead and run this code. And this should give us exactly what we want. Okay, so if we look at the entries in this vector here, okay, so we can see all the odd entries, the 1, the 3, 5, 7, 9, 10, 7, 9, 11, 13, 15, 17, all the way down there. So all of those have a value of 1, which is good. Okay. Then let's look at all of the entries with that's multiple of 4. So we look at 4, 8, 16, 20, and 24. Okay. So all of those have a value of 4, which is good. And then everything else, all the even number entries, that's not a multiple of 4. So 2, 6, 10, 14, 18, and 22, all of these have a value of 24. So that's exactly kind of what we want. Okay. So this code kind of does exactly that. All right. Any questions on this? All right. And so, definitely, take a look at these examples here. I know I went through them, fairly quickly, but hopefully, by talking through it and just hearing kind of my thought process behind these, it'll help with the homeworks. Okay. So one thing I want to highlight today and this is kind of a good example to do it, is if you'll notice that, whenever I could, I try to use the loop index as much as possible inside the loop. Okay. Okay, so when writing loops to visit entries in a matrix or vector, try to use the loop index as much as possible. Okay. Okay. And so the reason for this is that, sometimes, if you're looking at just a problem kind of just by itself, you might say that, this vector here only has 25 entries. Okay. And so, you might get into a situation where, you might get into a situation where you start hard coding some numbers. Okay. So what I mean by that is that, when you're writing a loop, you want to try to avoid referencing very specific lines in that loop without an if statement. Okay. And so, for example, so we know that this is our output here. Okay. You want to avoid situations where you want to say that, let's say that we know the 22nd entry of this vector should be 24. Okay. So you want to avoid situations where you say, vector ex2 at entry 22 is equal to 24. Okay. You want to avoid situations like this as much as possible. You want to basically try to make it or write your loop such that, everything that you need to happen just kind of naturally happens through the loop itself. Okay. Because, because we're going to come to situations where, we're writing our code. Okay, and you may be writing your code to solve a very specific heat transfer problem, but you also want to keep it flexible. And so if some parameters of the heat transfer problem change, and so let's say that you want to run the code on kind of a bigger domain, or maybe you want to increase the increase the thermal conductivity, or maybe you want to increase the amount of convection, you want to make it so that your code is kind of flexible enough to handle those kinds of situations. Okay. So this makes it so that your code and the reason we do this is that this is kind of the beauty of writing kind of computational code. It's right. And so when you look at one of the commercial codes that are out there, or even some of the open source codes like OpenFOAM or ANSYS, right? The way you use those softwares is that you don't have to rewrite the code to handle every specific situation. Okay? The codes for those programs are written in such a way that if you do change something, like you do change a boundary condition, or maybe you change your mesh a little bit, then the code is able to handle that due to the way it's programmed. Okay? So let me give you an example. And so if we look back at our example here, so let me define a new variable here called size. Okay. And so in our default case, the size of our vector here was 25. Okay? So maybe I change my code here so that it's written like this, okay? Where we're using the size variable. And so if we run this code, it should do exactly the same thing because size here is 25. And everywhere I wrote 25, I've replaced it with size. Okay? But let's say that, I want to write this code, but instead of a 75, a size 75 vector, instead I want to write it for a size 2,500, okay? And so if we run this code, you'll see that, just by making that small change, by using these variables as much as possible and avoiding kind of these hard-coded numbers, you can see that our code does exactly what it needs to do for 2,500. Okay. All right, so I'm gonna go ahead and run the code. Okay. And then let's kind of scroll down here to something just to kind of prove to you that it works. So let's scroll down to something kind of down here. Okay. All right. So now that we're doing this for a vector of size 2,500, right? It should still kind of follow that same pattern. So if you look at all the odd number entries, so here we have 1,713, 1,715, 1,717, 1,719. Okay, so they all follow the same pattern where, for all the odd indices, we set the value of the vector there equal to 1. Okay. Then we look at all of the entries who are multiples of 4. Okay. And so we'll look at 1,712. Okay. 1,716, 1,720. Okay. If you divide those numbers by 4, you should get 0. Okay. Or you should get 0 remaining, excuse me. Right. And so all of those entries have a value of 4. Okay. And then all of the even entries that are not multiples of 4, we set their values equal to 24. Okay. So you can see we're still following the same pattern, but the size of our problem has grown significantly. Okay. But because we wrote the code in kind of a clever way, we're able to handle a problem here that's significantly bigger, with very, very minimal changes to the code. So the only thing we really change is just the size variable up here. Okay. So we can change this back. I can even make it even bigger. So let's make it 9,864. Okay. You can run the code and you can see that our answer and our code updated for that. And we only just made kind of one small change up here. Okay. So this is kind of another kind of technique that we'll use in this class, is that we'll write our codes in a way that's scalable. Okay, so that's kind of the term that we use in computational, so that our code is scalable to different kind of problem sizes and different problem settings. Okay. All right. So if you look at the homework problem, homework problems, I know some of you have come up with solutions to them already. The solutions that I have are, with this kind of scalability in mind. Okay. And so to do that, basically, you try to utilize variables as much as possible. In particular, you use the loop variable as much as possible. Okay. All right. Any questions on this? All right. So the last thing I want to talk about in terms of MATLAB is kind of a more of a fun thing. This one's not not too difficult. Is the plotting function. Okay. So one of the beauties of MATLAB, or one of the really nice things about MATLAB, is that it makes plotting very, very easy. Okay. So plotting is great because a lot of times you're working on these very complex math problems with very complex engineering problems. The best way to kind of see how you're doing, or to see kind of the results of your simulation, is to visualize. Okay, because it's one thing to kind of run MATLAB and to use the workspace and to just look at the numbers. Okay, if you're very good at visualizing that, then that may be useful to you. But I think for most people, they like to see kind of like a graph, or they like to see a figure that kind of shows them how their code's doing. Okay, so that's exactly what plotting will do. Okay. And so to plot, this is kind of the standard that I use for plotting. So I do it kind of in a 2-line approach. And so the first thing that I do is I write a line of code that defines a figure. Okay. And so we have figure, in this case, figure 1, and then I plot on that figure. Okay. And the plot function, it takes two entries. And so the first entry, it is a vector that defines the x values for the data that you want to plot. And the second entry in the plot function is a vector that contains the y values, for the quantities that you want to plot. Okay. Okay. So let's look at an example here really quick. So I'm not going to type this one out just because it's fairly simple. But let's say that we want to plot the function y is equal to x squared. Okay. Okay. All right, and so we need to define two vectors. So we need to define a vector for the x values. And so for x, I'm making use of this linspace function. And so this linspace function gives us values of x between 0 and 5. And we want 100 entries of that. Okay. And the y value is just going to be x squared. Okay. And because we're doing a entry by entry operation, we want to apply the square to each entry in x. I'm using this kind of dot notation here. Okay. All right, and so to plot that function, we do figure 1 because that's the first figure we're starting with. Then we do plot x comma y. And then what I've done is I've added a couple extra lines of code here to label the x and y axes and to give our plot a type. Okay. All right, and so if you run the code, then you get a plot that kind of looks exactly like this. Okay. All right, so we'll be using the plotting function quite a bit. Later on in the class, I'll show you how to plot 2D functions, which is really cool, which is going to be useful when we do 2D problems. And then, yeah. All right, and so that concludes the MATLAB review. And so, I know we reviewed it in a week, but I think if you kind of mapped the content of what we covered this week to like 205, it would be probably, a few weeks worth of information. And so, it was a lot to cover in a short amount of time. But again, this was just kind of a review. So hopefully this was useful. If anything, looking at the examples and kind of, seeing how I thought about them, maybe that's probably hopefully the most useful thing. And so, starting next week, we're going to be, writing codes using a lot of the conventions that we talked about this week. Okay. All right. Any questions on this? Okay. All right, so we do have about 10 more minutes, and so I do want to kind of very briefly start the next thing. We're just going to kind of introduce this idea, and then we'll pick it up on Monday and kind of really expand on it. Okay? All right, so let me go ahead and close this. Share my screen here. Trying something new. I'm trying writing on my iPad in landscape form instead of portrait mode. Okay. Really nice. It kind of fills the screen a lot better than the, than the other one. I think I'll do this. Okay. All right. So for the last 10 minutes today, we're going to be talking about this idea of finite difference. Okay. So in this class, we are going to be learning computational heat transfer. And so we're basically going to be learning how to basically develop the code to simulate heat transfer phenomenon. And we're going to learn two principal methods for doing this. So the first method that we're going to learn is finite differences, and this, which is going to be the first half of the course. And then the second half of the course, we're going to learn finite volumes. So some of you may have already have some experience with finite differences. I know there are some teachers of 407 that go over this. But so I think it's good that you kind of have that exposure. But we're going to kind of approach it kind of from a more theoretical kind of point. Okay. So first, let me start off by writing out our general transport equation. So if you remember, from our review last Wednesday, we have this idea of a transport equation that can be used to model heat transfer. It can be used to model mass transfer and a lot of other things. Okay? And so we gave it kind of a generic variable. We called it phi. Something like this. So that was kind of our general transport equation. So, if we were solving the heat equation, we would replace phi with T. Okay, if we were doing mass transport, we'd replace it with concentration, which is normally C. Okay. But basically, a lot of fluid thermal systems and any kind of transport systems are governed by this equation here. Okay. All right. And so, throughout this first half of the course, basically up until our first midterm, we'll be solving this entire thing. Okay, but we're going to just be doing it piece by piece. We're not tackling it all at once. But the first thing I want to kind of highlight to you is the fact that there are a lot of derivatives in this equation. Right, and so our first order of business, in developing code is to kind of tackle those derivatives, because we need to kind of we need to have a strategy for that, so that we can take this equation and solve it using computer code. Okay, all right, and so that's where finite difference comes into play. The finite differences, it means kind of a lot of things, but in a nutshell, and kind of the way that we're going to use it is basically a way to take a derivative and transform it into an algebraic expression. All right, and if you look at all the other computational techniques, so finite volumes is exactly the same way. Finite elements, kind of the goal for that is exactly the same. So basically, you're taking derivative expression, calculus expressions, and you want to transform it into algebra. Okay, because the benefit of algebra is that once you can get a problem into an algebraic form, it becomes a lot easier for a computer to solve it. Right, and so the difference between all these different methods, whether it be finite difference, finite volume, or finite element, is the way that it transforms into the way it performs that transformation to an algebraic expression. The way it does it is different, but sometimes the end result is more or less the same. Okay, so finite difference is kind of based on the reason we start with finite difference, and in a lot of computational courses that go over the theory start with finite difference. The reason we do that is that it's pretty easy to visualize. And so the idea behind finite difference is to think about the way that you think about slope for a curve. So let me go ahead and draw a graph here. With several data points here. All right, so we'll call this the X and Y axes, and then we'll label each of these points here. All right, so in this case, we have 10 points. The exact number of points doesn't really matter all too much, but in this case, we end up with 10. And then let's assume that we know the exact X and Y coordinates for each of these points. We know x1, y1, x2, y2, x3, y3, so on and so forth. Okay, so we know the x and y coordinates, but let's pretend that we don't know the underlying function. So, let's say that this is maybe data that you collected from an experiment, and so you don't know exactly what the function would be underneath this. Okay. So let's say that we are given the task where we want to compute the slope of this curve at 0.4. Okay. Let me go ahead and write slope. And so if you think back to kind of your very first calculus class, when you're kind of introduced this idea of slope, what do we say it was? We say that slope was basically rise over run, right? So the change in vertical distance around a certain location divided by the change in horizontal distance. Okay. Is there a way that we can compute that based on the data that we have available, right? And so we know that 0.4 here is surrounded by points 3 and 5, right? So 3 is its left neighbor, 5 is its right neighbor, right? And so one way that we can compute the slope is to take the geographic information from 0.5 and 0.3. Okay? And so for the rise, let's take the difference in their y coordinates, okay? And say we'll do y5 and y3, okay? Because we know 0.5 here has coordinates x5 and y5. 0.3 has coordinates x3 and y3, okay? We'll take the difference in their x coordinates, right? And so, x5 minus x3. And so kind of from a very kind of just a purely visual perspective, this is how you compute slope in that location, okay? And what is slope? Slope is nothing more than just the derivative of that curve there as well, okay? And so what we have here is we use two things. And so we use the fact that we knew kind of the physical locations of the points around it, and we use our interpretation of slope as rise over run to come up with an algebraic expression for the derivative. And that's basically all finite difference is. And so finite difference, we're going to be building on this point, and we'll do it on Monday because we are out of time today. And so the idea with finite difference is to take this idea of rise over run and kind of the physical interpretations of rise and run and use that to represent all the derivatives that we need to. Okay. All right. Any final questions on this before we wrap it up for the week? Okay. All right. And so that's all we got. That's all I have planned for today. Okay. So we finished our MATLAB review. So hopefully you can do the homework now. Okay. Remember, the homework is due on Monday, 11:59. Please upload it onto Canvas if you can. Right. And if you have any questions on that, you can come to office hours. So I have office hours tomorrow morning and Monday and Wednesday. Right. So thank you guys for coming today. I know I went over a little bit of time, so thank you guys for staying a bit. I hope you guys have a good weekend, and I'll see you on Monday. Yes. Sure. Yeah.
So we're just doing it like PDF, right?
Yes.
So we're just doing screenshots.
If you can take the code, so there's an export function in MATLAB, you can export. I would prefer that, just so it's kind of nice.
So that okay, don't do screenshots.
Yeah, I would prefer kind of the export, just so it's easier to. Yeah.
It's export.
Yeah, export. So you go to file, and then there should be export. File. That's export. Yeah. No, it's just a variable.
So
Yeah, so basically the loop variables that we use, I call it row index just because it's, you know, just to keep track of that sort of row. Just always kind of remember that the loop indexes are kind of, it's counting up each time the loop comes. So basically each time you kind of reach the end and it comes back up, then the loop index. So the only kind of specialized functions that we use were mostly just to create. The zeros function was the main one. I know we used the mod function for today. That was kind of a special case. We're not really going to use that much in this course. It's kind of useful to do for examples, but you know, the only specialized function, the most specialized function that we use most of the time is everything else is mostly. Yeah. Yeah.
Did you discuss convergence with us?
No, I guess I didn't get to that. So that would be at the end of the first lecture. The lecture notes 0-1. Yeah, normally I don't do that. Normally I try to cover everything in the class, but yeah, we just didn't have time. But the idea with convergence is that, you know, the smaller you make, the smaller your grid size, the smaller. Yeah.
You missed it. You took the left and the right points to find the slope.
Yeah.
Would you tackle it differently for points 1 and 10?
Yeah, you would. And so that's a great question. So we're going to tackle that next time. So basically for points 1 and 10, where you don't have a left and right neighbor, you would basically just do a reduced version. So you would just do like 1 and 2.
All right.
And so the slope would be y2 minus y1 over x2 minus x1. Yeah.
And for a MATLAB code, it'd be like its own separate statement.
Exactly. So that's where kind of if statements come into
Yeah.
play. And so you would have to do something differently. Yeah, good question. But then there's you take a hit in that case because that's not going to be as accurate. As
Yeah, there's no neighbor for that.
Exactly. Yeah, that's a great question.
Thank you.
Thanks. You too.
Sir, can I add you on Steam at the end of the semester?
Yeah, maybe over summer. Yeah, not sure. After you graduate, that's the safest time. You guys. You too.